Hello everyone, I'm Chris Spinagle from the Warning Decision Train Division. I'd like to welcome you to today's Storm of the Month presentation. Today's presentation comes to you from the National Weather Service in Paducah, Kentucky. Our presenters are Justin Gibbs and Derrick Snyder, who will be giving a presentation titled Didn't Think That Can Happen, the April 2nd, 2024 derecho tornado outbreak and widespread comms outage. With all that being said, Justin, the floor is yours, so go ahead and take it away.
All right, thanks, Chris. We're excited to be here and tell this story. It's a pretty wild night, even by Weather Service standards. To give you the setup for what happened early, we staffed up. We had a pretty standard high ceiling, highly conditional event. We had a very strong capping inversion in place that had held convection back. There was a small risk of discrete convection in the warm sector early. That didn't pan out. Wasn't a huge surprise, but we had a massive trough that we were concerned about giving us a QLCS tornado threat in the overnight and a just QLCS wind threat. And yellow just is how many people we added to our standard. Yellow on our schedule means we changed what was planned, or either overtime or extended. I come in on just a straight up after midnight shift, coming in about 9 o'clock p.m. And it was a good thing we got here early. As we were setting up, we got a call from our friends over at Springfield saying, hey, we're about to hit the deck. We've got a big line coming. We got tornado circulations close. So we backed up WFL Springfield for 5 or 6 minutes, and we issued 2 or 3 warnings, and both of which verified. I looked back later, and there was like 28 reports in the warning we issued. They had about 78 to 80 mile an hour measured wind gusts. They had a couple tornadoes right by the office. But even in that moment, when we were backing them up, we noticed that data in AWIPS was really sluggish. And we were on the phone and opened a ticket with NCF. And you can see in our log, one of our leads entered that ticket at midnight 20 Central Time for AWIPS was sluggish. It wasn't working as well as we'd like. We kind of had trouble getting our warnings out and doing the things that we needed to do. And they started investigating that. Literally about 10 minutes after we got off the phone with NCF, we have a status board light here that shows our local data manager and our regional connection, internet connection, all the stuff. When it turns yellow or red, it means something's wrong. In this case, there wasn't anything wrong on this night, but that light lit up, which is our first clue, something's not right. The VSAT light lit up, which is our backup satellite. We said, okay, I think we're down. So we tried to send a special weather statement or something. We tried to send something. I don't remember exactly what it was. It didn't go. We said, uh-oh. We got back on the phone with NCF, and I said, well, I guess we're going to go to backup. And they said, well, tell me your backup office, and I'll see if they're up. I said, Louisville. Said, they're down. So what about Springfield? They're down too. Okay, Davenport, Iowa. They're down too. Wait a minute, what's going on? And at that point, I think all of us realized we had a major problem here. Probably realized that a little slower than St. Louis and Springfield that were actively doing tornado warnings at the time. But we picked out, from what we could tell, we didn't have the ability to transmit anything for about 12:30 to 12:55 a.m. Central Time. We were not getting any outside products at all. Part of the way we noticed is our adjacent radars were not updating, and our satellite data wasn't coming in, but we could see our radars. SPC sent out a mesoscale discussion talking about they're going to do a watch in our area. We never got it. It never alarmed. And the NIMNAT, when they decided to coordinate the watch, never alarmed. We talked to our partners in Slack and said, hey, yeah, we've got a national outage. Radar data's not coming in. We get that. We're working the problem. And we did have the distinct advantage of not actively being in warning ops for at least about 30 minutes during the worst of the outage. So backup is not an option. We tried that again. And we're telling our media partners we can still see radars. We can still see warnings. Data came in, and then we came back up enough that we got our climate out at 1:25 a.m. and we could tell we could at least issue warnings. So we cut off all the grid updates, anything that would, if we were maybe using VSAT, we weren't sure, just limit it to warning text for the next little bit. And we saw the mesoscale discussion on our Twitter feed, and that's how we knew they had done it. So we realized the watch was probable, but then we never got the NIMNAT. So SBC called us and asked if we were going to be on the call. We said, what call? And we pulled it up. We knew the number, you dial it a bunch around here, and dialed into the call. The WCL did not come across, and we hand coordinated the Brian Smith, I think, was the one that was on at SPC. He told me what counties he wanted. I colored them in GFE, and he gave us the watch number. When Twitter posted the watch from SPC, I sent it out the WCN manually from here. which I've never done before, but it worked. Just in case you need to know, it does work that way if your WCL never comes in. Everything matched up. We didn't have any trouble. And then we took the office iPad and posted the watch to social media. Since Graphic DSS and our other web-based products were not sending anything out in a timely fashion. And this map, as you can imagine, didn't get rave reviews from our users as far as, where am I at? You know, we got folks that don't know what part of the county they're in, let alone picking out their unlabeled county on a map. So we learned as we went about how to communicate. We also discovered an important point. Our emergency override in BMH and weather radio was not working. We tried to get ready to do emergency override because we thought, hey, if we lose AWIPS functionality, we can at least transmit over weather radio. But that wasn't working. So we were like, now we're really going to have trouble. We knew we could talk over Slack and Facebook and all these private sector channels, but we needed something official that we could send it out on. And while we're doing that, we're trying to pump radar. We took pictures in with the office iPad on Slack and said, here's the radar and here's our polygons, and tried to give them more information than what we would, because tornado warnings are out. We've got TV partners that are wall to wall, and shared the polygons of radar images. We also shared that on Facebook and Twitter as well for the general public to see. Saw a rumor about 1:45 that the weather service is down, nothing's getting out, there's not going to be any warnings. So we jumped in and did a Facebook Live using OBS Studio. Only took about 4 minutes. So we said, we're up, we're here, we can see the radar data, and we're issuing warnings, and as best we can tell, those warnings are getting out. Now, what I do feel pretty confident is we had trouble with the wireless emergency alerts. Those didn't go out as well as they were supposed to, but that's honestly can be kind of hit or miss anyway. We did that Facebook Live to say, hey, we're here, everything's under control as best we can see the data, we will warn on it if we can see it. And at one point I turned the webcam to AWIPS to try to show the radar, and it didn't work very well, it wasn't very clear, but it gave me a little bit of an idea as far as getting data out. Our ITO had set up a direct feed from AWIPS to our file server to where GR2 level 2 files populate, and that's how we populate our GR2. And it may be fairly common, I'm not sure, but I'd never seen it before coming here. So I was able to get GR2 working on my PC, which had access to the internet through our Wi-Fi backup, I believe. I don't remember if the internet was down during this period or not. The internet was down at some point, but at this point it wasn't. And we have 2 or 3 redundant backup internets. So I started streaming the radar live using our Paducah and Evansville feed. I got on and said, hey, this is what we're doing. And then I muted myself and shrunk the window down and said, here's what we've got. We did that for 2 hours and 47 minutes. Every now and then we jumped in and said, hey, here's what we're doing. But I was issuing warnings too. So there wasn't anybody to say, hey, we're going to do a live TV-like feed. I wouldn't want to do that anyway necessarily, but we certainly didn't have the people and the resources that night to do it in such a widespread event. We ended up with several tornadoes over the next little bit. We issued very large polygons, and I'll explain that in just a minute, and then smaller polygons for the tornado warnings. And even though this doesn't look very impressive reflectivity-wise, it was blowing 60 to 70 knot inbounds. It was rocking and rolling as it was moving through. This was, I believe, up here we had an EF2 tornado, maybe an EF1 down here. Most of these polygons were producing tornadoes. And we just proceeded to absolutely get worked for the next several hours. It would have been a heck of an event had everything been working, but it was especially made more unique by the fact it wasn't. We tried through the event to keep Slack active. We've got a great Slack channel with our partners. They're all, okay, here's what we're seeing, here's what we're thinking, here's where Derrick was like, strong rotation, and then next volume scan, still seeing strong rotation. And he's working radar while he's doing all this too. We're getting the damage reports, the typical stuff, but we're trying to give the on-camera meteorologist something to talk about, because I know at one point I looked up and the OCMs were using, they had their phones pulled up and their iPads pulled up to our Facebook feed so they could see the radar while they were talking to the people that the people at home could see was blank map and our polygons. That's all they could see. So we tried to keep the radar up so they could see, okay, here's where I see storms and it's moving through here, now it's moving into this town, and kind of radio style describe what they were seeing based on our feeds. We tried to do individual tornado warnings, which in this case, these tornadoes were separated by like 4 miles. So I would have probably done the old line of tornado producing storms, one single warning. But with this, we were able to give the TV people and the general public a little more idea of where the storms we were worried about were with those single individual polygons. So there's a storm near this small town, there's a storm near Metropolis, there's a storm west of Golconda, and it seemed like it was maybe a little easier for the meteorologist on camera to track and talk about it. I can't imagine the torture that being wall to wall with no radar data to talk to must have been. Just atrociously scary to think about. And knowing how hard wall to wall is, even in the best of circumstances, we had tornadoes all over the place, and every one of these produced at least a little something. You can see the little circulations. And you also notice it was getting pretty close to us by that point. We're co-located with our radar. So about 10 minutes before the storm arrived here, comms were still going in and out. And I wanted to make sure we had at least some warning out. So I got a little liberal with my interpretation of what 12 counties means. I'm sure at some point in history there only took up 12 counties because our counties are pretty small. But this was a 64-minute, 26-county warning, the third largest polygon the office has ever issued. It was extended, the idea being just we're going to scream at everybody that's in the way. And if we go down for 5 or 10 minutes, which we've kind of been doing, we would still have something out even if it wasn't a tornado warning. And I was also worried because our comms will fail in bad weather, even under good conditions. So the idea that we get 60-knot winds in a tornado and we lose our comms was not zero. So that would have given us some time to kind of figure out what to do. There's our third largest polygon there. Most of them were early in the storm-based warning era. And then sort of another big takeaway from this, about 5:15, that storm was approaching. This would have been a layup shelter in place for us under normal circumstances. We would have went to the break room. But who was going to take over for us? We were the only people in the world that could see the radar data, and we were working some pretty big tornadoes, you know, EF2s and EF1s, widespread wind damage, and they were spinning up in like 0.3 of a second. It was the fastest I've ever seen QLCS tornadoes spin up. So we couldn't just abandon ship or the service would have fallen to the floor. So we said, I guess everybody get away from the windows. Now this wasn't like an EF4. If we'd have been tracking something like that, I think we would have had to put we would have had to have taken cover. But looking at the damage in history, we made it challenging. All of us that were on that night kind of talked later about what could we do differently. And we said, well, this will never happen again. But then I thought, well, there's another comms outage a week later. Maybe it would be good to have a plan in case something like this happens. So not an ideal situation, but we were fortunate we didn't have any trouble and the comms stayed up. And if they hadn't, I don't know what would have happened. But out of the frying pan of the fire, I'll hand off to Derrick here to talk about his experience, which was maybe wilder than mine.
Thanks, Justin. So I kind of titled my section, When Training Becomes Instinct, just based on my experience with this event. It was definitely one of the more crazy events I've worked in my career with the Weather Service. So while all the chaos is happening here at the office in the evening hours with having to go to the backup for Springfield and then the comms outage, I was blissfully asleep. I had worked the day shift the day before, and I knew when I left that evening that there was a potential I could be called in early, but also there was a lot of uncertainty with the timing, the meso-analysis, all that stuff. There was a lot of disagreement among the models, especially when it came to things like capping, where we're going to have a strong capping version that was going to limit storm coverage, or the storms would even be surface-based or not. So it was a very, very difficult event to forecast, regardless of the communications challenges that we had. So my phone rang a little after 3 in the morning. I was, basically asked to get here as soon as I could. I got to the office around 4 o'clock. When I walked in, I don't believe we had internet access at that time, so I really didn't have a lot of time to really get spun up with things like meso-analysis, looking at the cams, observations, that sort of thing. We did have extra people in the office, but we were limited. We had, unfortunately, some folks were out sick. It was also spring break here in Paducah, so we had some forecasters that had taken that time off to go spend time with their kids, which is totally understandable. So by the time I walked in, the folks in the evening shift had been in the office for over 14 hours at that point, and I could tell just from the body language that we had some extremely tired people working by the time I had gotten spun up in AWIPS and with radar. So by the time I got spun up, it was pretty apparent that, the initial line that we'd had tornado warned that Justin had showed in the previous slides was starting to intensify a bit as it raced towards, the image here is from the BWX radar in Owensville, Indiana. It was showing the QLCS approaching in southeast Illinois, approaching the Wabash River in southwest Indiana. And basically, I really didn't have a lot of time to even think about, when it comes to your training, especially with QLCS warning decision making, like, are the 3 ingredients being met? And I just kind of had to say, I'm just going to assume they're being met, and I'm just going to kind of roll from here. So I issued my first tornado warning less than 20 minutes after I got into the office, and then the next 2.5 hours are kind of a blur. As the line approached the Ohio River, so I issued my first tornado warning, I think it was 9:19Z. By the time we got, a little over an hour later, the line had really intensified and began to accelerate very quickly, which was subtle at first, but became more apparent as the event went along. There seemed to be several different processes at work to develop mesocyclones and QLCS tornadoes that I remember from the 3 ingredients method training: descending rear flow jets, reflectivity tags, cell mergers, bookend vortices, all those things were happening in one way, shape, or form. Thankfully, another one of our forecasters, Andy Lesage, arrived at 4:30, and I became really apparent that I'm not going to be able to pick out all these circulations by myself. So Andy sat next to me, and he spun up about a half an hour later, and then for the rest of the event, we kind of tag teamed these warnings as it went across northwest Kentucky and southwest Indiana. And a little bit about southwest Indiana. Evansville is actually our biggest city in our forecast area by quite a bit. So it's, it has its own media market. A lot of times the town the office is in is the biggest in the CWA, but in this case, we're a little bit odd like that our biggest city is actually a couple hours to the northeast of where our office is located. So Andy got spun up, and we worked the rest of this event. Basically, everything was going so quickly, and when we're issuing the warnings, we're also trying to turn around and get onto NWS chat and describe what we're seeing, and so the media folks up there could actually describe what we're trying to warn. So as we got closer to the 11Z timeframe, so this would have been about between 5:30 and 6 a.m. local time. So just the first light, people are just getting up, going to work and stuff like that. Numerous circulations developed along this line. It was really actually difficult to keep track of them all. And like Justin said at the beginning, we were trying to issue warnings for the individual circulations, but eventually we kind of had to give up on that. By the time we got to this 1053 Z-scan off of BWX radar, there was one point there were 4 individual circulations along this line, and so we kind of had to flip gears to the squall line capable of producing destructive winds and numerous spin-up tornadoes. And I also want to point out the 2 scans here, which these were 10 minutes apart. The line had actually moved about 30 or 40 miles in that 10-minute span, and so the line was just rocking and rolling through the area. And it was something that was kind of a learning experience for me, and I think it was something that really drove home being proactive with your warnings, because you see a TDS on radar, you do an SVS. In the couple of minutes it took me to do that, the storm was almost out of my box. So it was really difficult to keep up, and then trying to communicate this with our partners that didn't have access to this information and get the warnings the way you needed them to be. Eventually, the reflectivity and the velocity singers we had a lot of de-aliasing issues due to just the extreme, I think, straight line winds as the line really, the QLCS really started to gust out. So we weren't really sure if this was producing a tornado at this point, or it was just producing 100 knot winds or something like that. But I didn't put it on here, but we did have a destructive severe thunderstorm warning out for this area in addition to a tornado warning, basically hoping that the WEAs were activating for something to get people's attention. And then, we issued very large warnings to get it up to our CWA border, and then have it into our partner office to the east in Louisville, so they would be able to gear up and take over the warnings for them. So we got into the let's just get out of here mode by this point. The damage surveys of this would be worthy of an entire talk on its own. It took us over a week to survey all the tornadoes. This one warning I mentioned that had 4 different circulations, it actually produced 4 separate tornadoes, 2 EF2s and 2 EF1s, as well as a swath of very severe straight line wind damage right through the north side of the Evansville metro area, and also where the airport's located. So it was it was just as extreme as it looked on the ground as it looked on radar. And in addition to the circulation, some of the tornadoes merged together and ended. Some of them gusted out into straight line wind damage and downbursts. It was a very, very challenging event from warning and a surveying perspective. Just to kind of wrap up here, this event produced 19 tornadoes total. 7 of them are EF2s, 11 EF1s, and there's a typo on the third bullet point. It should be 1 EF0. That was 115 miles worth of tornado tracks. That was the 8th most for one day in our forecast area's history since 1950, and also the most tornadoes in one day in our county warning area in over 10 years. So, and I put an informative link there to the event summary page if you'd like to learn more about this event, their mesoanalysis and things like that. But with that, we'd be happy to answer any questions you might all have.
You reminded me, at one point I put a track in GR2 to get the storm motion, and it was 61 knots. And I'm like, that was early in the event. I'm like, uh-oh, this is probably not great.
Thanks, Justin and Derrick, for that presentation. We are looking for presenters, and so feel free to reach out if you have a topic you'd like to present on. As a matter of fact, we have an opening as early as next month in August. We're still looking for a group, so if anyone's interested in participating and presenting something there, please reach out and let us know. Otherwise, thanks for your time and attendance, and enjoy the rest of your day. Thanks, everyone.